Okay, so this is the exam that Year 12 sat this morning, and I'm going to go through it to make sure that you guys know what to do. So the first question here, we've got to multiply out the brackets, and we've got to end up getting x equals, or x is less than. So if we multiply out the brackets, we get 3x minus 6 is less than 8 minus 2x. We then get all the x onto one side, so we've got to get rid of this minus 2x by adding it onto the left-hand side, and get rid of the minus 6 by adding it onto the right-hand side. And if we do that, we end up with 5x is less than 14. So x is less than 14 over 5, which you can also write as x is less than 2 4/5, but you don't have to. Okay, the next one here, whenever you've got a quadratic inequality, which you'd get if you multiplied out the brackets, you'd get 2x squared. What you need to do is you need to sketch it. So every time you have a quadratic inequality, we sketch it. Now if we multiplied out these brackets, if we do this times this, we get minus 7. So therefore it's going to go through the y-axis at minus 7. And it could be that if it's in this format, you multiply it out to start off with. So that's going to be 2x squared, it's going to be minus 7. And then you've got plus 2x, and then we've got minus 7x. So we end up with 2x squared minus 5x minus 7. So that's going to go through at minus 7. And then to find out where it goes through the x-axis, we need to factorise it, which is what they've given us to start off with. So then this one here, we've got the solution x equals minus 1, so it's going to go through at minus 1. For this one here, we need to set the bracket equal to 0, so 2x minus 7 equals 0, 2x equals 7, x equals 7 over 2. That's going to be 3.5, or 7 over 2 there. And we're going to sketch it. So just going to go through there, there, and go back up. And the reason that we know that it's a positive parabola, or a smiley face, is because it's positive x squared. And what we need to know is we need to know where this graph is less than 0. So if we have a look at the graph over here, it's less than 0 for this bit here, which is underneath the x-axis. There's only one bit of the graph here. If it said it's greater than 0, there'd be 2 bits of the graph there and there where it's above 0. So we need to have 2 inequalities. But for this bit, it's only one bit of the graph, which is below the x-axis. And that is when x is less than 7 over 2, but greater than minus 1. So that's the answer for that one. So it might be worth writing down that 7 over 2 is 3 1/2. Again, it doesn't matter if you've left it at 7 over 2, but for the purpose of the next bit, it is useful if we know that it's 3 1/2. So if we were to draw a x-axis here, 0, and we draw the inequalities, so the first one is x is less than 2 4/5. So 1, 2, 3. So 2 4/5, and it's strictly less than, so we don't colour in the circle. It's going to be down there. That there is 2 4/5. And then the next one is x is less than 3 1/2, but greater than minus 1. So 3 1/2 is here, minus 1 is here. So if we join that together, we've got that there. So the part of the graph, or part of this diagram, where there's 2 lines, is in between these 2 bits here. And that is when x is less than 2 4/5, but greater than minus 1. That's it. That's what we need to do for that one. And it's reasonably straightforward if you've done a few of these questions, but if you haven't, it does take a little bit longer. Okay, question 2. Show that x squared plus 6x plus 11 can be written in this format here. Now, you should have done enough of these questions now that you realise that when this thing here means completing the square. So what we do is we halve the coefficient of 6x. So it's going to be x plus 3 squared. Take away this thing squared, so take away 3 squared plus 11. And we stick this bit on the end. That's going to be x plus 3 squared. Then let's take away 9 plus 11, which means plus 2. Fairly straightforward, but it's 2 marks. Find the value of the discriminant of this. Now the discriminant, we need to know that this thing means b squared minus 4ac. So b squared is our value of b. The value of a is going to be 1, not that f. And the value of c is 11. So b squared is going to be 6 squared. Take away 4ac. Now 4ac I always stick on brackets. So it's 4 times by 1 times by 11. So that's 6 squared minus 44. It's 36 minus 44, which is minus 8. And we don't need to describe that, but because it's negative, because our discriminant is negative, what that means is that there's no real roots, because it's less than 0. And what that means in terms of if I wanted to sketch it, it would mean that my graph doesn't actually touch the x-axis at all. Okay, question 3. Given that this equation here has no real roots, show that this is less than 0. So if it says no real roots, that means the discriminant is less than 0. So the discriminant, of course, is b squared minus 4ac is less than 0. And writing this here is usually enough to get the first mark. So b squared minus 4ac is less than 0. If we substitute stuff in, our value of b is q. That's going to be q squared minus 4ac. So that's going to be 4 times by a. Now remember, a isn't the x squared, it's the thing that's in front of the x squared. So that's 2q times by c, which is going to be minus 1. And that's less than 0. That's going to be q squared minus, in brackets, minus 8q. So minus 8q means q squared plus 8q is greater than 0, which is what they've asked us to prove there. Now it says find a set of possible values of q. So we know that q squared plus 8q has got to be less than 0. So what we do is we've got to find out all the values of q that do that. So if we set this up, imagine that said x squared plus 8x is less than 0. Find out all the values of x that make that true. So if you add 15 squared plus 8 lots of 15 isn't less than 0. So I want to find out the values of x that does make it less than 0. So I'm going to sketch this. So whenever you've got a quadratic inequality, you need to sketch it. So we're going to factorize it. Q bracket q plus 8 equals 0. So then q equals minus 8, and this one here, q equals 0. So 0 and minus 8. And because it's a positive q squared, it's going to look like that there. So I want to know where all of these, or where this graph is, again I'm going to point to this bit here, less than 0. And the bit where it's less than 0 is going to be this bit here. And that is when q is less than 0 but greater than minus 8. And that will make this here less than 0, anything in that range. Okay, it may seem tricky at the moment, but the more you see of these questions, the more familiar it comes, and in the end it becomes second nature. Okay, next question. So you've got a sketch on the axis below that there. I'm going to zoom out a little bit. There you go. So if I'm going to sketch this, if I was to multiply that out, that would be y equals 4x minus x squared. So now we've got a negative x squared, we've got a negative quadratic, which means it looks like that. And I want to find out where that goes through the x-axis and where it goes through the y-axis. So to find out where it goes through the y-axis, we set x equal to 0. And if x equals 0, that's going to be 4 lots of 0, take away 0 squared, so that's going to be 0. So it goes through at 0, 0. And then I want to know where it goes through the x-axis. Let's make y equals 0. So that's 0 equals 4x minus x squared. And with any quadratic, if you're going to find out where it equals 0, you're going to factorize it. So 0 equals x bracket 4 minus x. Then this one is when x equals 0. And this one is when x equals 4. So we've got 0, 4. And we know it's going to be a negative parabola. So it's going to look something like that. Okay, now the next one, we're going to sketch this. Let's multiply out first of all. So we've got y equals 7x squared minus x cubed. Now again, you've got a cubic, but instead of being a cubic that looks like that, it's a minus x cubed. So it's going to look like that. And what we've got to do is we've got to find out where it goes through the x-axis and the y-axis. And if we draw this one in red, so to find out where it goes through the y-axis, we set x equal to 0. So that's going to be 7 lots of 0 squared, which is 7, which is 0. Take away 0 cubed, that's still going to be 0. So x equals 0, y equals 0. So it's going to go through there. We then need to let y equal 0. So we're going to have 0 equals 7x squared minus x cubed, which we then factorise, which they've done for us over here. We get x squared 7 minus x. So that means it's going to go through at 0. That's going to go through at 7. However, the issue being is that a cubic, or our cubic, negative cubic, is going to look like that. So we need to know what that's going to do, because we've only got 2 points of intersection at 0 and 7. Now, because we've got something called a repeated root here, because we've got this one, this solution, where we had it x equals 0, that's squared, which means it touches 0 twice, and it goes through at 7. So it means it's going to go down. Go touch that one. It's going to go up. And it's going to go down like that. And that would be how you sketch that. Now the next question, it says, show that the x-coordinate, show the x-coordinate of the point of intersection of these two things are given by the solutions to this equation. Right, so if we're looking for the solution at the point of intersection, which is going to be this point here and this point here, that is when, also, and then because this graph here goes down steep and this one goes down less steep, because this one's an x cubed and this one's an x squared, they're going to meet somewhere down there. The points of intersection are when this graph equals this graph. That's what points of intersection are. So to find out where points of intersection are, you set one graph equal to the other graph. So I want to set this graph equal to this graph. So I do x bracket 4 minus x, because I know that y equals this and y equals this, then this thing can equal this thing. So x bracket 4 minus x equals x squared bracket 7 minus x. And then they want us to rearrange it so it looks like this, which should be easy enough. We're just going to multiply out the brackets. So 4x minus x squared equals 7x squared minus x cubed. Now, let's get everything on, because if we multiplied out this set of brackets here, the answer, which we don't need to, but that will give us x cubed, so we want a positive x cubed. So, because we've got a negative x cubed here, we're going to get everything onto this side and set it equal to 0. And if we do that, that's going to be x cubed. That's going to be positive x cubed when we get rid of that. Then we're going to take away this. That's going to be minus 7x. So you've got minus x squared minus another 7x squared. So that's going to be minus 8x squared. We've got plus 4x equals 0. Then to get from this to this, we've got to factorise out an x. Because like I said several times, if ever you've got to factorise a cubic, which is something to the power of 3 in C1, all you do is you factorise out the x first of all. That's going to be x bracket x squared minus 8x plus 4 equals 0. And that's that. Okay, next question. Solve the simultaneous equations. Let's give ourselves a little bit more room to do this question. Right, okay, so the first thing you do when you're solving simultaneous equations is you've got to use substitution. So I need to have either y equals or x equals. So let's have y equals 3x minus 2. If we can substitute that into this, that's instead of having y squared, you're going to have 3x minus 2 squared. Now rather than 3x minus 2 squared, I always say that you need to write that out as two brackets. So 3x minus 2, 3x minus 2, minus x minus 6x squared equals 0. Then if we multiply that out, using the smiley face method, you're going to get 9x squared, and then you're going to have minus 12x plus 4, because remember, minus 2 times minus 2 is going to be plus 4. You have minus x minus 6x squared equals 0. Now it could be that you want to do this using more than just that step there, because obviously if you do the nose, it's going to be minus 6x. If you do the mouth, it's going to be another minus 6x. Simplify minus 6x and minus 6x, and that's where I got the minus 12x from. Okay, and then going to simplify this, that's going to be 3x squared minus 13x plus 4 equals 0. I'm going to factorise that, hopefully, if it factorises. So 3x and x minus 4 minus 1. That leaves me x equals 4. And then for this bracket here, it looks a little bit more complicated. So 3x minus 1 equals 0. 3x equals 1. X equals 1/3. So that's that and that. So then once I've got the x coordinates, I need to find out what the y coordinates are. And I know up here, it tells us that my y coordinate is 3 lots of my x coordinate, take away 2. So if x equals 4, 3 lots of that take away 2, it's going to be 10. If x equals 1/3, 3 lots of that is 1, take away 2, and y equals minus 1. Again, being able to do that is worth a fair bit. It's worth 7 marks, which is almost 10% of your grade. Okay, question 7. Now, as I said a second ago, you're never asked to factorise this, or factorise a cubic, unless you take out the x first. So if we take out the x, it's going to be x bracket x squared minus 4. And then not going to give you 3 marks for that, so you need to be able to factorise this bracket here. So that's going to be x bracket x plus 2, x minus 2. So you've got to recognise this as the difference of 2 squares. And then what you've got to do is you've got to sketch this graph. So if I were to sketch that, I substitute in x is 0, so if x equals 0 into this, and then 0 cubed into this, then 0 cubed is 0, take away 4 lots of 0, 0. So y equals 0. So I know that this point lies on the line. And then you've got to substitute y equals 0. So you've got 0 equals x bracket x plus 2 bracket x minus 2. And you've got to set each of these equal to 0. So that's going to be 0. That's going to be minus 2. That's going to be 2. Therefore, it's going to go through at minus 2, 0, and 2. Now, because you know it's a cubic, we know that cubic looks like that. So it's going to go up there, down there, and up there. And that's that one done. Again, 6 marks, which if you do a fair bit, or a little bit of practice with, you should be okay. Right, so let's have a look at question 8. I'm hoping that when I come to mark this, this should be quite a strong question for people, because of the fact it's been on all your tests so far and it's been subject of quite a bit of support. So the first thing we've got to know that if we've got a square root on the bottom and it's 2 plus root 3, You've got to times top and bottom by 2 minus root 3, which is what we call the conjugate. Okay, then we do the top and bottom using the smiley face method. So 5 times 2 is 10, minus root 3 times minus root 3 is going to be plus root 9, or plus 3. You've got the nose, which is minus 2 root 3, and then you've got the mouth, which is minus 5 root 3. Then on the bottom, if we do the same, you're going to have 2 times 2, which is 4. Root 3 times minus root 3 is minus root 9, plus 2 root 3 minus 2 root 3, which those cancel. So on the top, if we do root 9, it's going to be 3, so that's going to be 10 plus 3, which is 13. Minus 2 root 3, take away 5 root 3 is minus 7 root 3. And on the bottom, 4 take away root 3 is going to be 4 take away 3, which is just 1. In which case we can leave it as 13 minus 7 root 3. Okay, so let's have a look at question 9 then. So the power of a third means the cube root. So the cube root of 125 is 5, because 5 times 5 is 25, times by 5 again is 125. So the next one is 125 to the power of minus 2/3. Now the first thing we deal with is a negative power. So that means 1 over 125 to the power of 2/3. And the way we deal with this, we deal with the bottom first, which is the cube root. And once we've done that, we deal with the top, which is the power. So it's going to be the cube root of 125, which is 5. We then square it. That'll give us 1 over 5 squared, which is 1 over 25. Okay, and then question 10. Now question 10 goes back to question 1. And pretty much everything that we need to do for it. So, step 1, we want to get all the x on the one side, all the numbers on the other side. So we get the x onto the left-hand side and get rid of the 3 and put it on the right-hand side, which leaves us 5x is greater than 10, x is greater than 2. Okay, here we've got a quadratic inequality. So we're going to sketch it. We know that goes through at minus 12. Because when x equals 0, it equals minus 12. So we're going to factorise this. So 2x and x. And let's try 4 and 3. So you want minus 8x plus 3. Yeah, I think that works. So then, if we set that equal to 0, x equals 4. So it's going to go through at 4. If you do this one, then 2x plus 3 equals 0. 2x equals minus 3. X equals minus 1.5. And it's a positive x squared, so it's going to look like this. And we want to know where this graph is less than 0. So again, it's just this bit here where it's less than 0. And that's when x is between 4, but it's greater than minus 1.5, which we said is minus 3 over 2. Now again, for part C, you want to know where it fits both of those. So we draw our x-axis and we sketch those on. So the second one here is minus 1.5, is that one there. And our first one was when x was greater than 2, so that looks like that. And so where this graph has both lines is from there to there, and that is when x is less than 4 but greater than 2. And it's so easy if you just sketch out this diagram. Okay, let's have a look, see how many questions we've got here. Okay, what I'm going to do is I'm going to pause the video there, just so that you've got that video done, so you can look through that video and really absorb it, take it in and make corrections, and then I'm going to do a second video for the second half of the test.